Hello and welcome back to the channel. My name is David Young and I'm a computer science student at Concordia University, Chicago. Today is the second episode in our series on the basics of software engineering. Today we're going to be talking about the differences between software engineering and software programming. If you haven't seen our previous episode on an introduction to software engineering, I would encourage you to go back and watch that because that's going to lay the groundwork for today's episode. Then next time we're going to be talking about software processes and methodologies. How is software engineering implemented in practice? Then we'll talk about real-world software costs. What does the budget of a software project look like? And then finally, we'll talk about challenges and professional issues that arise for software engineers. Um, Before we begin, I'd like to ask that if you enjoy this video, you would like and subscribe and share it so that more people are able to see this content and learn about the wonderful field of software engineering. So you may be wondering, isn't software engineering the same thing as programming? And while these terms are often used interchangeably in common discourse, there's actually a pretty interesting and important distinction between them. So let's first define what software programming is. Typically, when we're speaking of software programming, we're talking about projects that are going to be undertaken by one developer. So this is not team-based work. This is a solo project. The applications that are undertaken are usually relatively small. So even if they're in the thousands of lines of code, they're not anywhere near the software solutions that are being developed for enterprises in terms of scope. They're going to have relatively minimal code, and they're also going to have relatively minimal documentation because that's simply not necessary. These projects have a short lifespan. Typically, when we're talking about software programming, we're not talking about things that are going to be upgraded or maintained. They're just going to exist for a short time. There's not going to be multiple versions of them released, and bugs that aren't breaking the program are going to often be left as they are. There's also few stakeholders in software programming projects. What this means is that the architect is often the same person who's using the product, is also often the same person who's developing that product. These are not going out to a wide and diverse user base. They're often developed for the person who is programming them, maybe as a utility or something for convenience, but not as something that's going to be sold necessarily or given to other people. These systems are going to be one of a kind. So they're not typically going to be built with reuse in mind. They're instead going to address a very particular issue, and they're not going to be super flexible often. Also, these are going to be standalone projects, so they're not going to depend on a lot of other programs and applications, and they're usually not going to be depended on by other programs. They'll stand by themselves and be used sort of in isolation in a lot of ways from other programs. They're typically built from scratch, so we're not going to see a lot of reuse because, once again, these are purpose-built programs. There's not going to be typically a lot of existing um, solutions for this. So here's an example of a software programming project for a Caesar cipher. This is something that I worked up in about 20 minutes. So you can see that it's a relatively short lifespan, and the code here is very minimal. I just have the main function and then my encoder function. A Caesar cipher, of course, is a cryptographic cipher where text is rotated through the alphabet by a certain amount of shift. You can see here, this is the entirety of the user interface for this program. I haven't invested in a lot of code for a user interface because I'm just using this myself and I don't need it to be pretty and nice. And you can also see here that I haven't done a lot of standard practices for programming, like to make this more reusable. For instance, separating it out into a header file and a file that includes the code. So you can see how this is a very lightweight application. This isn't going to be a heavy hitting thing, and I'm also not going to probably upgrade this or evolve this in any way. It's going to exist as it exists for the rest of the time it's useful to me, and then I'll probably delete it. Now let's talk about what software engineering is in contradistinction to software programming. So software engineering is going to be a team project. And so different team members are usually going to have different roles within a software engineering project. For instance, the project manager, a tester who's working on just simply testing the code, making sure that it works. You might have people who are working on the front end of a project, so what the user sees, and then the back end. But this is going to be undertaken as a team. It's not going to be a solo thing. The applications that are going to result then are going to be very complex. So in the many thousands of lines of code. Because of this complexity of these projects, as we talked about, they need to be designed. You can't just have a bunch of people writing separate code and then figure out how to put it together. You need to carefully design and manage your teams so that they can work together effectively and address these complex problems and integrate these applications well without causing problems. Software engineering projects also have an indefinite lifespan. So unlike the example I just showed, software engineering projects are designed to last a long time. So an example of this is going to be Microsoft Word, which is a 42-year-old application. So 42 years ago, the original code for that was written, but of course, that's needed to be adapted to new systems. It's needed to be evolved. Software engineering projects aren't typically built with a time limit. They're going to need to continue to be maintained and evolved. And so this is why documentation is particularly important when we're talking about software engineering vis-a-vis software programming. As your teams are rolling over, so you have new people coming on and old people leaving the project, you're going to need to have a way to have people understand what's going on. Documentation is going to be that method. Moreover, as Dr. Victor Govindaswamy notes, maintenance accounts for over 60% of overall development costs. So what this means is that you're not just paying to develop your application, but you're paying, in fact, the majority of your costs to make sure that that application continues to work. And the system must be able to grow. We call this scalability. So when you have a system, you're not going to start with as many users as you'll eventually have typically. Think about like a social media platform like Facebook, which has just grown and boomed into billions of users. You should software engineers are aiming to design their code so that it's able to grow, that features are going to be able to be easily added without needing to rewrite the entire program, and that it can handle an increased workload and increased user load, etc. These are the kinds of considerations that software engineers are going to take into account. There's also many stakeholders in a software engineering project. The architect of the project, the person who is designing everything, is not going to be the person who's coding everything necessarily. There's going to be a huge team of developers, and there's going to be managers of that team. There might be a testing division that has the sole responsibility of testing that project. And then it's going to be developed not for a personal project or an interest or something that's going to be a utility, but it's going to be developed on behalf of a customer often. And then moreover, the person who is using it is not the same person who developed it. And so there's a lot of people who have a stake in software engineering projects. Also, these software engineering systems are going to interact with other systems. So you might think about how Microsoft Word, for instance, is part of the Office 365 suite. And there's also Microsoft Word for mobile devices, Microsoft Word for Apple devices. So there's a broad range of systems that are interrelated, and this is what we call system families. These software engineering projects are often going to have to integrate with other systems, which is going to create dependencies. And so think about the way that, for instance, Microsoft Word relies on your operating system. These dependencies are something that you're going to need to be mindful of when you're doing software engineering. Also, software engineering, because it's these big projects, every little bit of money saved counts. And so software engineering is going to rely on reuse of other code and existing code and making code that is in turn reusable to diminish the overall cost of a software engineering project. So an example of a software engineering project that we alluded to earlier is Facebook. you can see over here a development team for Facebook. So it's not just a single developer, although that's how it started. It's not just a single developer. In fact, Meta has tens of thousands of employees working on Facebook. And so Facebook started small, but it grew and it ballooned into this big thing. And so you're going to need a team to maintain that. You can't maintain that by yourself. And so that's an example of when software engineering comes in to make sure that a project is going to be well maintained and grow over time. So let's summarize some key differences between programming and engineering. Programming is going to be a solo endeavor, whereas software engineering is going to require strong teamwork. Software programming is typically going to lead to some small scale programs and results, and those aren't going to be evolved. But software engineering leads to results that are scalable. So as the user base, for instance, increases, the program grows with it, and the program is going to evolve over time also. And in software programming, systems are going to be short-lived, and they're not going to be well maintained. But in engineering, systems are designed to last. And so they're going to be maintained by teams, and they're going to be designed to be relatively easier to maintain, and they're going to exist indefinitely and have to be adapted to new technologies. So here's a glimpse at, and this is not super technical, but it gives a glimpse as to how teams are structured for programming versus engineering in a company. And so you can see here we have a programmer, and he's interacting with a manager. This would be an example of software programming because it's a single developer who may or may not report to a manager, but is going to be undertaking a project by himself. Now, this manager may have other programmers reporting to her, but overall, you can see how this is a relatively small group of people who are involved in this project. Now, over here is an example of software engineering teams. All of these lines are relationships and interactions between team members. And so you can see how software engineering relies strongly on teamwork. And we're going to talk later about how that can have strong benefits, but it also introduces challenges that we're going to have to be aware of. Thank you for watching this episode. Next up, we're going to talk about software processes and methodologies and the implementation of software engineering principles. Please leave any questions that you have in the comments of this video, and don't forget to like, share, and subscribe. Thank you.